Welcome back, Dragons. We're on page 17, like terms. One thing we need to review before we dive into this one is the algebra tiles. This is going to prove why certain terms are alike and other terms are not. Now, if you're feeling unsure of what a term is, we did discuss those back on page 6, parts of an expression. 4W is an entire term, 6 is an entire term. The mistakes people made on the quiz, they said 4 was a term and W was a term. They're together. They can't be separated. These are not two terms. This is one term and this is one term. That is the coefficient, the variable, and the constant. So if you're unsure, go back and study 6. Let's resume with 17. Like terms. We have the X tile, the Y tile, the X squared tile, the Y squared tile, and then we had some individual constants. This little red square represents 1. We also have an XY tile. It's not as used commonly at this level. This is gray. These are green, this shows up orange, and this is red. If you didn't borrow any tiles this weekend, that's fine. You could just draw them out as you need them on the activities. I'm going to keep these to the side so I can make a point here. Like terms, that's what goes in this first blank. Like terms have the same variable with the same exponent. What do they mean? Okay, this tile here, this is x to the power of 1. This tile here is x to the power of 2. So the exponent on this one is 1. The exponent on this one is 2. That proves that these are not alike. Now if I have 2 of these with each an exponent of 2, they would be alike. Just as if I had 2 of these with their singular exponents, these 2 would also be alike. That's what they're talking about there. All constants are like terms. Constants means a red goes with a red goes with a red. They're all in the same group. None of these red ones represent a variable. They represent constants. So right there, I have the number 5. It is not like the other blocks. And constants can always go together because, quite frankly, they're just regular numbers. Like terms can be added or subtracted. I'm going to zoom in on that answer key there so you can see what got filled into the blanks. Now, hopefully you already glued in the foldable here that we did together in class. I'm going to review what makes them alike and what makes them not alike. All right, under like terms, hopefully you color-coded. This first row, they're all X. They all have a singular X in them. So that means I have, in this one, 3X, I have 3 of these. This one means I have 2 of these, 10 of these, 5 of these. That way I could put them all together if I wanted to. Now these are all constants. That means I have 8 of these, or 4 of these, or 7 of these, and so on. Therefore, all those could be combined if we wanted to. Here is your x squared row. What this is saying is I have 5 of these, 7 of these, 1 of these, 2 of these, which means you could combine them if you'd like. Now we don't have a W tile, but it's the same concept. And this is a Y cubed tile. This is a cube. We don't have this tile either. But you can see because they are all Y and they all have the same exponent of 3, they would go together in a group. Now, if it's all different things all over the place, they are not like terms. You can't combine a y and an x. You could see they aren't even the same. So don't try to put them in one group. It doesn't work that way. Can't combine w's with c's and so on. You also cannot combine things of different power. An x squared is not the same as an x cubed. This would be a square. This would look like a cube if I owned one. And then this is just that. So you can't put unlike things together. They're in different groupings. Now what we're going to do on this last part is find and group. Highlight or circle each group of like terms a different color. So we're going to need a variety of colors here. I'm going to take out my highlighters. You can pause the video and take out some highlighters as well. And then we will work together to find things that are alike. Okay, let's start. I see that a 3x would go with a 2x. Looking for other x's, which would go with a 5x, which would go with a 7x. That looks good. I'm going to leave this color out just in case I need it. Next color. Let's find our constants. 8 can go with a 1, which can go with a 3. Who else do you see? Which goes with a 6. And I missed this little guy. It goes with a 12. That looks good. All right, I see some Y's there. Let me find another color. Let's just do just the Y's. Now this is Y to the power of 1. This is Y to the power of 3. They can't go together, so I'm just going to circle the singular Y's. 4Y, 7Y. When I say singular, I meant exponent was singular. 6Y, 5y. That looks about done for that. Let's take care of those y cubed. Those would be a cube shape. We have 4y cubed, 5y cubed. This is 1y cubed. 11y cubed, 9y cubed, 8y cubed. They were happy with these cubes. I've got a 7y cubed hiding over here, and a 2y cubed. All right, we have 3 of them left. Let's see if they belong together. X squared, x squared, x squared. Looks good to me. Last color. Last color. 8x squared goes with the 9x squared, which goes with the 5x squared. All right, dragons. That's it. You combined like terms. Thank you again for joining me. I'm going to move on to page 18 next.